Good morning, everybody. Today we're going to talk about the different concepts in sample survey. And the aim of my talk today is to motivate for the different types of sampling that we're going to be discussing in Statistics 395. What I hope is that by the end of this module, the end of this talk, you'll be able to visualize the sampling process, the different types of sampling processes, and have some idea of exactly how it's conducted, though later on you'll get more into understanding the different advantages and disadvantages of the different sampling procedures. So let us start off by realizing that in the old days, there was very limited computational ability. For example, when I started university, an entire floor of electrical engineering on Howard College campus housed a computer, a single computer that the University of Natal Durban had in those days. And this computer had less computational ability than the phones that you're carrying in your pockets today. So really, in the late 70s and 80s and 90s, there was no way that we had computational ability that could handle very large data sets. So what in those days we thought of various ways of making it easier and to rather not deal with large data sets. And one such a way was to select your data from a larger data set. And for example, what we call, you're all used to the notation, you would have come across it in first year. You have a large data set, which we call a population, and from that we select a sample. We work on the sample, but we try and select it in a manner that it has a similar structure to the original data set. For example, you can see here there are more red ones than yellow ones in our population, so it's nice to note that similarly in the sample, and so on and so on. So when there was limited computational facility, it made sense to work with different ways of reducing your data, but in particular sampling being one of those days. Now the question arises, how relevant is it in this day and age to still sample? Is it necessary? Why would one sample? You've heard about data science, big data, and so on. We have masses of data now, but we also have much better computational facilities than we had in the old days. So let us look into how necessary it is in this day and age to sample. Now, you might have heard of the fourth industrial revolution, and just as the name suggests, industrial revolution means something that drastically changed the industry at that time. To start off with, when you talk about we're in the age of the fourth industrial revolution, you should at least know what the first three were. What was the first one? When did it occur? The second and the third, and so on. So let's just briefly look at this. The first industrial revolution was in the 18th century, and that was because of steam-based machines. What that means, for example, in the old days, before the 18th century, the industry or whatever was being made was just sold locally, and there wasn't really the facility to cheaply carry large objects across many miles. So when trains were introduced, for the first time, industry could take whatever they were manufacturing and at a relatively low cost transport it to faraway places to sell. And that had a huge effect on the industry, and that was the first industrial revolution. Then 19th and 20th century was the second industrial revolution, and that is energy-based mass production. Now you must probably have seen these conveyor belts where parts come past, and maybe a particular person just assembles a screw into the wheel of a car, and they just put a certain number of screws in, and the next object comes and they put the same screw and so on. You've got this conveyor belt, and that is the kind of, or tins that go past, and there's machines that just put a label on, and the next in comes, puts the label, and so on. So that is this type of energy-based mass production, conveyor belts, and so on. You can see it up there. That's 19th to 20th century. And then again in the 20th century, presumably later in the 20th century, was what is called the third industrial revolution, computer and internet-based knowledge. What this is saying is, for the first time, the records and everything in the industry was actually based on was computerized. With other words, for example, the record keeping and all their processes, they would have defined on computers. And then again, early in the 21st century was fourth industrial revolution. That's where we are now. So this is the age when artificial intelligence and information, the data that's in a cloud and Internet of Things and so on, together is changing the industry. And that's where we are now, the fourth industrial revolution. We spoke about this in our previous the previous class I had with you as well. But this, for example, is where you would go to a shop, you buy tiles, you buy adhesive, you might buy a tile cutter, and then when you get to the till has figured out that you must probably doing a tiling job and will say, hang on, people that buy tiles and a tile cutter and some kind of adhesive most probably are going to be doing tiling, but they also buy grout, and this person forgot grout. And then a message will come up on the screen. So what it means is the computer is interacting with the human that's buying stuff. And this is a whole new revolution leading to big changes in the industry, industrial revolution, where computers and people together will change the face of the industry. So the data science, we spoke about this in the previous class, but really what we need to know is we always have to extract knowledge or insights from data, whether it's in the earlier ages or whether it's in the data age. We are always wanting to do that. And what we know is that in this day and age, it's very easy and very simple to gather large amounts of data. And it's all written up here, but I'm going to focus on this last one, business data, customer behavior, tracking at fine detail. Why would people want to do that? Because they want to stay ahead of their competitors. So they want to understand what people are buying, what should they be advertising to which group. So the common themes in this is that the common themes here is that sorry, let me just put this off. The common things are data is large and growing, the important trends and patterns in data and so on, and we need to understand where to look in the data. So it's just because we can capture big data doesn't mean that we have to work just with the big data. It's not always possible to store data in full. There are many applications and so on, and it's convenient to work. It's often inconvenient to work with all the data. And if we could find a way to reduce the data to something more sizable that you could work with, it would be an advantage because it's faster for a company to rather work with compact data, and it's better to explore it just on a laptop. Now, you'll look at the heading says 10 statistical techniques data scientists must master, and I found this article which was published by James Lee in October 2017, and data scientists, with other words, in this fourth industrial revolution that we're in, have many techniques that they need to master, but these 10 that they mention are very interesting, and I'm not going to read them all out, but I want to point you to the one that I've got in red there, the third one, sampling methods. So even though we're in the fourth industrial revolution, where we're now really engaging with data science, sampling methods, and in particular mention of resampling, is still very important, and it's one of the 10 top skills a data scientist needs to have. So what is the sampling? I think you're all very aware of it. We have a population and we select from that a sample. So we're basically reducing the size of your data. And we know why we're doing it. But sampling has intuitive semantics. We obtain a smaller data set, but we always try and have the data set to be representative of the original bigger data set. With other words, we select a sample in a way that it makes it representative of the population. And we do estimation on the sample so that whatever we find in the sample will tell us something similar about the population. So we can run smaller scale estimation, but in a manner that we make sure that we do as best we can to find out more about the population. And then there's mention here that when you've sampled, there might be need for rescaling or reweighting. And you'll hear much more about that in this module as we go along. But what we're basically saying, for example, if you're selecting 1 in 10 of every population element, you take 10% of it, then when you're doing the estimation, you have to remember to scale it up so that you get back to the population. But really, we'll talk more about that later. Sampling idea, the concept is very easy to understand, and people have a basic understanding about sampling. But it doesn't mean that sampling is the only way that we can reduce our data. It's not the only game in town. There are many other data reduction techniques. I'm going to put them up here. I'm not going to waste my time to go into that. They're all worthy of study, but the one that we're interested in Stat 395 is the different sampling techniques. So, sampling. You know about population. It needn't be people. It could be Coke bottles or whatever we're interested in looking at. And we're going to select a subset. We're going to call it a sample, whatever it might be. And we want to look at the different ways in which we can sample so that the sample that we get is representative of the population. Now, when you read sampling books, they start off about talking about probability sampling, non-probability sampling, and resampling. 3 different kinds of sampling. What are the differences? That's the first concept I need you to understand. And I found this article in Towards Data Science. Here's the reference. And this is how they define probability versus non-probability sampling. Now, assume every dot here is this is your population, and the ones that are colored in are the ones that were selected. So there were, in this case, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. There were 35 elements in my population, and we selected the colored in ones. Now, if you look at these two, you can imagine if you just randomly selected 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we selected 11 out of the 35. If you look at this, it's very conceivable that you just randomly selected and you happen to take these dark ones as indicated. But nobody would think that this here was just by chance the ones you selected came up like a perfect cross. It's fairly obvious that this one was chosen purposefully, with other words, not selected fairly or randomly, and this one most probably was random. So we talk about probability sampling and non-probability sampling. What is the definition? The difference lies is whether the sample selection is randomized or not. Now, the word randomized means you can think of it as fair. Here, it looks like they chose fairly. Here, somebody pre-decided or decided, I'm going to make a cross. This isn't fair. That guy never had a chance of being in. That one never had a chance of being in the population. So this is not fair. So that's the non-probability, meaning this isn't selected randomly and you've given everybody a chance. This is where it was. So this is probability sampling and this is non-probability sampling. But then it's very interesting. This website gives a definition here. It says the difference lies whether the sample is based on randomized or not. That's true. But they say with randomization, every element gets an equal chance to be picked. And I hate to tell you, but even though it's a website, and you must be careful when you just read off any website, this is actually not true. It's not true that when it's probability sampling, every element has to have an equal chance. It just has to be, I'll show you what I mean by that. Probability sampling is when it's possible to find the probability of an element in the population being selected. It's possible to find the probability, but it doesn't mean that it's all equal probability. Suppose, and I'll demonstrate by example, suppose there are 12 students and we want to randomly select 3, 1 per row. So my 12 students are 7 in row 1, 2 in row 2, and 3 in the last row. I'm going to pick 3 students, 1 per row, and I'm doing it randomly. I'm not going to cheat and say I'm definitely taking that one. I'll say there's 7. So I give them each a number. That's number 1, 2, 3, 4, 5, 6, 7. I pick out of 1 to 7. I pick a number. Suppose I pick number 6, I pick that one. If I pick number 2, I pick that one. So it's random. I can say the chance of one of these getting into the sample, I'm picking 1 from that row, would be 1 over 7. This row, there are only 2. The chance of selecting that one is 1 out of 2 because I'm picking 1 from that row. Here, that one's got a chance of 1 over 3, 1 over 3, and each one's got a chance of 1 over 3 because I'm randomly selecting 1. So, probability sampling means the probability selection might differ depending on which row the student is in. So, probability sampling is when it's possible to find the probability of an element being selected. It's not true that they equal because I'm picking 1 from this row, they've each got a chance of 1 over 7. 1 from this row, they've each got a chance of 1 over 2. 1 from this row, each of a chance of 1 over 3. But if I said I'm picking the first, the middle, and the last, that wouldn't be probability. That would be non-probability sampling. It means I've just made up my own mind. I didn't randomly select. So, we're going to look now at different sampling schemes. And in fact, I mean the sampling schemes that we're going to discuss in this course. Suppose, and I'm going to take a really simple example, where we have a total of 15 elements in our population, and we want to choose 5 for the sample. The first I'm going to look at is simple random sampling. That can be with or without replacement. So simple random sampling with replacement or simple random sampling without replacement. These are 2 different types of sampling. Now suppose I've got a population and I made it really simple. My 15 people look like this. 1, 2, 3, 4, 5 in a row. There are 3 rows. There are my 15 people. And I wanted to select 5. Here they are. It doesn't mean I selected that one first, by the way. I just put numbers 1 to 15 in a hat. The first one I picked out was actually this one, number 1, 2, 3. Picked out number 5, so he made the sample. And then I carried on and on. And it says, if you randomly want to select from a class 5 students from a class of 15, simple random sampling without replacement means if I choose this one, then there are only 14 next time. And I pick another one, then there are only 13. And I pick another one and so on until I've got my 5. But if it's with replacement, if I pick this one, I note number 5, and then I put him back before I pick the next one. And you'll become more familiar with what I mean as I go to the next slide. So I picked 5, 1, 2, 3, 4, 5. Here they are. My black shirt, 2 red shirts, the pink and the purple. There they are. Now, in this particular example, same example, so that's my population, that's my sample. Simple random sampling with replacement. So I chose this one first. I replaced him. Then I chose that one. Suppose it's that little man. So the chance of this one being selected, he's the first one, the 15, was 1 over 15. But because I picked him back, I ended up picking this one, but that happened with a chance of 1 over 15 because I put that one back. There's still 15. That one was selected with a chance of 1 over 15 because I also selected that. I put that one back before selecting that one. So that is why all these probabilities are 1 over 15. However, if I'm doing simple random sampling without replacement, the first time round, they're all there. So to choose that one has a chance of 1 over 15. But now remove him, he's gone. There are 14 left. So I chose that one next, and that happened with a chance of 1 over 14. I took him out. That one got chosen with a chance. There were 13 left, 1 over 13. So now that one's gone, that one's gone, that one's gone. There were 15, so there are 12 left. When I chose that one, the chance that I should have chosen him was 1 over 12, and lastly 1 over 11. So whether you replace or not affects your chance of selection. But I can work them out. So simple random sampling is definitely a probability sampling process because it's possible to find the probability of selection at any time. The next type of sampling I want to talk about, and we'll spend quite a bit of time on this, is something called stratified sampling. We again have our 15 people in the population or students, but this time we've got a different population. We've got 5 wearing red shirts, 5 wearing blue shirts, 5 wearing yellow shirts. Again, we've got 15 and we want to choose 5. But I've put all the red shirts into one, what we call stratum. You can think of the word stratum as a group. I've just put them into a section. The blue shirts are on stratum 2 and stratum 3. Now I want to pick, for some reason we've decided we're going to have a total of 5 students in our sample. From the class of 15, we've got 3 strata defined, and we're going to pick 2 from stratum 1. So I put number 1, 2, 3, 4, 5 in a hat, and I pick one. Suppose it's that one. I pick again, and I got that one. So they went into the sample. The same then separately, I did 1, 2, 3, 4, 5 into a hat, and I picked 2 first. So the stratum 2, I picked that one. Then I picked 4, so that one went in. Then again, I put number 1, 2, 3, 4, 5, but from stratum 3, I only picked 1. So when 3 came up, it's in. So now, in the end, I've got my 2 red guys, the 2 blue, and the yellow. So the sample is the joining of the ones that I picked from each stratum. So in short, stratified sampling means you take your population, you put similar groups together, and then you choose a particular number from each stratum. Here, 2 from stratum 1, 2 from stratum 2, 1 from stratum 3. So the question comes now, how do you know how many? How do you know which ones to put in which stratum? Here it was easy. The red shirts were stratum 1, blue shirts, but it's not like that. Normally people don't run around wearing particular colored shirts. How do we know which ones go in the same stratum? How do we know how many to select from a stratum? And how do we even know when is stratified sampling better than simple random sampling? Well, that's what this module is about. We're going to talk about those things. Then there's another kind of sampling that I want to talk to you about, and it's called cluster sampling. Cluster sampling is also where we have the population and we divide them into groups, like in the strata case. We put all the red ones together. You can see here, last time we just had 3 colors. Now we've got more colors. We've got red guys, we've got the blue shirts, the yellow, the green, and the purple. We've put them into one group. This is cluster 1, all the red. Cluster 2 are the blues. Cluster 3 are the yellows. Cluster 4 and cluster 5. But out of these 1, 2, 3, 4, 5 clusters, we picked 3 entire clusters. So in cluster sampling, you also put them into groups like in stratified sampling, but you don't pick from the sample. You don't say this is stratum 1, let me take some of them. You take the whole cluster if you pick that cluster. So you've got 5 clusters and you pick the entire green cluster. You pick the entire cluster. So stratified sampling is where you make them into groups and then you pick some from every group. But cluster sampling, you put them into groups and then you pick some of the groups but pick the whole group. So in single stage cluster sampling, you divide the population into the different groups. Then you say groups are clusters. You select entire clusters. That's an important word. So in this case, my sample looks like that. We've got the 6 red ones, the 3 green ones, and then the 5 little purple ones. So you need to, in your mind, always visualize. When we start talking about the mathematics, it should be clear. Then we have 2-stage cluster sampling. Again, you put your elements into the clusters just like before. But now you chose 3 clusters just like before. But we don't take the whole cluster. Last time we said in one stage, if I took this cluster out of the 5 clusters, I picked 3. I got the red ones, the green ones, and the purple. But now I don't take the whole cluster. In 2 stage, I say there are 5 there. I'm going to pick 3 of them. And you put, sorry, there's 6. So I put 1, 2, 3, 4, 5, 6 in a hat, and I pick out, and I got those 3 with the circles around. So elements from within the chosen clusters are now randomly selected, and I get this kind of sample. So I don't have all the red ones just because I picked cluster 1. It turned out there were 3 red ones chosen, that green one, and that purple one. So you can see that in this case, it's a little bit different. It's sort of a combination of stratified and cluster sampling, and it's called 2-stage cluster sampling. Then the next kind of sampling is called systematic sampling. And this is a very interesting one. Item in the population are chosen at regular intervals. What do I mean by this? Suppose my population looks like this, and you can think of it as a database, maybe Excel sheet. This is person number 1. He's in row 2 of the Excel sheet, 3, 4, 5, 6, and so on, and it can go to thousands or millions, it doesn't matter. But the data is linked linearly. Then we randomly selected a number from 1 to 4, and we actually got number 3, and thereafter select every fourth one. So number 3 was chosen. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15, and 15 plus 4 is 19. So your sample is selected at regular intervals. So my sample is number 3, 7, 11, 15, and 19. So what was done here, number 3 was chosen, by the way, randomly. Then after that, every fourth one. And that is called systematic sampling. Once again, we need to think, when is systematic sampling the right kind of sampling to do? When is it better than, say, just simple random sampling or stratified sampling or cluster sampling? And that's what this module is about. How do we use the different types, but also how do we know what are the advantages or the different disadvantages? Multi-stage sampling is really a combination of a few sampling methods that we've described. Now, the example I'm going to put here is population is put into clusters, and each of these numbers at the top row are clusters. As you can see, a circle here is a cluster. So that's cluster 1. Next circle, cluster 2, cluster 3, and so on. There were 10 clusters. Then clusters are divided into strata. Strata, remember, is groups. We say cluster 1 and 5 and 9 here are similar. They're all reds. So we put them into this group. And we call the group a stratum. The yellow ones, that's a cluster. There's lots of things inside it. That's another cluster. There are lots of population elements inside it, and they're both classified as being similar or made yellow here. And we put them into another stratum and so on. And then what we say is this stratum now has got cluster 1, cluster 5, and 9. And as we always do in stratified sampling, there are 3 of them. We're going to pick some. We picked 2. 1 and 9 was selected. It turns out cluster 1 here had 2 little stars in it. 9 had those 2 stars. They're just showing you an example. And here, those were the clusters. We chose 7 and 10. So this is a stratum. It had cluster 3, cluster 7, and 10. 2 were chosen there, 7 and 10. And all the elements in 7, there were those 2, all the elements in 10. So those 2 ended up being. So the sample is actually this bottom left. Remember, each of these have got lots of elements in them, and because it was chosen, we know now those 2 were in that original cluster. Strata were the squares, and the items, with other words, the elements in the population that eventually end up in the sample are these stars. So, an example. Suppose we want to interview people. We want to ask them something. Are you happy with service delivery? Whatever we're interested in asking them. How do we know? We want to choose people from big cities, small cities, rural areas, whatever. So now we don't. How are you going to decide who to interview? Well, the first thing you're going to do is you're going to say there's some very big cities in South Africa. Johannesburg, Durban, Cape Town, Bloemfontein, whatever. You put all the big cities in the one group. Then in another group, you put the maybe smaller towns, Dundee, Escort, various around the country, little towns, Middelburg, whatever. And then you've got maybe rural areas because you want people from all the different areas. Are you happy with service delivery? Then you pick a big city, and from that city you might send when they pay their rates and taxes, you ask them a little questionnaire that goes with that. So you send to everybody, say this is Johannesburg. Johannesburg was chosen. So everybody that lives in Johannesburg got with their rates and taxes a statement with maybe 2 or 3 questions related to what we're interested in. So you pick a city, and then within that city, you look at everybody. So that's an example there. So basically, I've been talking only about all these different probability sampling procedures, which means in the end, whoever we chose, no matter what the method was, you can work out the probability that this one was chosen because it's probability sampling and we have a method and we can say We know there were 3 cities and we chose 2 out of the 3, not favoring. We didn't just say we feel like choosing one. There's a random choice and we could work up. But it doesn't mean this one being chosen is the same probability as that one being chosen, because we can have different probabilities of being chosen, but we need to be able to work out the probabilities. And we'll talk much more about that as the module goes on. But I've mentioned non-probability sampling. What exactly is this? Remember I said that's when it's not done, you can think of it not fair, you can't work out the probability, you can't determine what the probability is of that element in the population falling in the sample. One example of that is convenience sampling. You're given a problem, say by me, I ask you to interview 5 people, I'll give you some questions to do, and you decide you're going to speak to your mother, your granny, your best friend, your aunt, and your uncle. What is the probability that you select that person? Nobody knows, because it just went by what's in your heart, what you feel like doing. So that's definitely not a probability you can work out. You didn't put all your friends in a hat and then pick one. You just said, I feel like speaking to that one. So there's no probability you can assign to that. So it's non-probability sampling. Then there's something else called quota sampling, where before the sampling is even done, you decide beforehand, I'm going to speak to 10 people. I want at least 4 to be, for example, say black females. I want 2 white men. So you decide beforehand strictly what you want. And when people come, once you've got your, say, 2 white men, a 3rd white man comes to be interviewed, you ignore him. So that is where you're now starting to bring bias in, and you can't work out what's the probability of that person being selected because you're ignoring some and taking others. Then there's another type called volunteer sampling, where the sample consists of volunteers. For example, if I say I want to choose 3 from this class of 10, who wants to be in the sample? If, let's for example, say this person in the front puts his hand up, I can't say, because there are 26 of you, the chance that he put his hand up is 1 in 26, because people have different personalities. Some won't put their hand up, they would never volunteer, and others will definitely volunteer. So it's not equal probability, and I can't say because there are 26 people, each one has got a chance of 1 in 26 of being chosen because they put their hand up as volunteers. So you need to say, for you to be in the sample, I ask for volunteers, I can put a probability that you would volunteer, and I can't do that because, as I say, it's affected by personality. So now the next thing we have is something called snowball sampling, and I'm just mentioning this because I think it's interesting. You might hear about it and not know what it is. So, for example, suppose we have 20 randomly selected patients, and we ask them to ask 10 of their friends each a question. So what snowball sampling is, this guy was selected, he asked his 2 friends. This friend asked that guy and that guy. This one asked that one. And you can imagine why it's called snowball, because it keeps getting bigger and bigger. You select one and you tell each one of them, like a pyramid scheme almost. So now, what is the probability that this one would ask this one? Well, he's got so many friends, nobody again can work it out. So here's an example. It's often used in HIV/AIDS, where people won't openly discuss. So you just say confidentially ask your friends. So there are times when we do it. But what's important, we try and avoid non-probability sampling. So this snowball sampling, volunteer sampling, quota sampling, we don't really, well, certainly in this course, we will not be discussing any of that, because the scientific inference from sample to population is very important. You want to say my sample is representative of the population, and then you use those probabilities to select the sample, to work backwards so that you can take your sample data to draw inference about the population. So again, the 10 statistical techniques that you need to be able to master include sampling techniques and data sampling, which we've been talking about today, is where we use the population, and we might want to know the mean of the population or a proportion that belongs to a certain category, and we look at only the sample, and then we investigate the sample and we draw conclusions about the population. And the types that we're going to look at that are called data sampling, and these are all probability sampling techniques: simple random sampling, with and without replacement; stratified sampling, with and without replacement. Then we're going to look at cluster sampling and systematic sampling. But we're also going to look at data, and I mentioned at the beginning, resampling. Now remember, I said data resampling. What does this mean? This is where you've collected your data set, your sample, but you don't stop there. You say, I've got the sample, and I want to see how to improve the estimate. You work on the sample to get some idea about the estimation of the population. And we do that by using the sample again as if it's a population. What I mean by that is from your population, you draw a sample. Then from the sample, you draw a subsample or a mini sample. And then you estimate back to the sample and then see what you can learn about the sample so that you can adjust when you're trying to estimate from the sample to the population. It sounds very complicated, but really once you understand how to do it, and we'll be talking about it in this module, it's very interesting and very useful. And we're going to look at something called the bootstrap resampling. And in fact, this will fall under Professor Zewata. So we're going to study classic sampling, probability sampling, definitely not non-probability sampling, and resampling technique, the bootstrap, as these methods are definitely required in predictive modeling in this modern era where we're in the fourth industrial revolution. So that's the end of my talk, and I look forward to the next chapter where we will be getting deeper into the sampling techniques.